Well, hello. Today we're going to be talking about square roots and irrational numbers. And then one of the usages for that, of course, is the Pythagorean theorem, which we'll get to that, but ultimately that's finding the third side on a right triangle. And oftentimes those are irrational numbers. So let's begin by talking about square roots. Okay, so the area of a square is 36 square inches. So inches squared, like a lot of people think of it just as a label. What's the length of each side? Well, if the area of the square is 36, and a square, of course, means that whatever one side length is, which if we don't know, I'll just call it x, then the other side must be the same thing. So something times something ends up being 36 square inches. What number multiplied by itself equals 36? Well, 6 does. 6 times 6 equals 36. Therefore, the side length of our square is 6 inches. So it's 6 inches by 6 inches, and then of course when you multiply 6 inches times 6 inches to just check, that's when you get 36, and then inches times inches is what gets us the square inches. Okay, so the side length of this square is 6 inches. Let's go ahead and take a look at a few of these. I have a couple examples down here. These all come out to be pretty nice. So the first one that we're going to look at here is if you have a square that is 16 square feet, then each side, you've got to think what times itself is 16, and that would be 4, specifically 4 feet. What times itself is 9? 3 is. So 3 feet. That means that this square is 3 feet on the left side, and it's actually 3 feet on every side, right? 3 feet times 3 feet is 9 square feet. Now this one might be a little bit trickier, but 1 square yard, what times itself is 1? Well, just 1 actually. So this is 1 yard on a side. So you could think of laying down a yardstick, and if you lay a yardstick down one way and you lay a yardstick down the other way across it, and then if you turn that into a square, then that area is 1 square yard. Down here, we have to think about these fractions. Something times itself gets us 4, in which case we'd say the top of this fraction is 2. And then we also have to think about what times itself is 9, and that would be 3. So we have 2/3 times 2/3, or 2/3 yards squared. Then for the last one, sorry, not last one, almost last one, 36, we actually already did that one. That one's just 6 feet. And then 25, what times itself is 25? That's 5 feet. So 5 feet on a side. Okay? Now, if you go through and look at these, you can see that, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. But those are what we call perfect squares, okay? These are perfect squares because a nice integer number times itself results in that. That's why these are perfect squares. But there are lots of numbers that are in between 4 and 9. There's lots of numbers between 16 and 25. Okay, so we kind of got to think about that for a minute. What about this one? What times itself is 30? Well, I don't know. I mean, I do know that 30 would fit right in here. 30 is between 25 and 36. So it must be some number between 5 and 6. And I mean, I don't know what that is. I mean, I could just kind of guess and say like, whoa, why don't we guess maybe like 5.4? We'll just guess a number like partway in between. So if I take and guess 5.4, and let's do 5.4 times 5.4. If you multiply that out, you get 29.16. You say, oh, okay, well this side must be a little bit bigger than 5.4. I bet it's 5.5. And so if you take 5.5 multiplied by itself, we end up getting 30.25. You say, oh. You say, well, 30.25, that's actually too big. it must be somewhere in between 5.4 and 5.5. And so you can kind of keep playing this game, like maybe it's 5.45. 5.45 squared, or times itself, is 29.7. So you'd say, well, that's too little. It's got to be a little bigger. And it turns out that that's actually something that we would call an irrational number. And it means it's going to keep going. It's going to keep going on forever. Like the number times itself to get us 30 is radical 30. As far as a decimal goes, oops, I don't know why that jumped up. As far as a decimal goes, though, I will tell you this, that it comes out to be something like pretty close to 5.477225557. I don't know. It just keeps going. Of course, I'm not going to make you guys do that. I used a calculator. Okay? So is the length of this side a whole number? No, it is not. What whole numbers is it between then? Well, we would say that it's between 4 and, not between 4. We would say that it's between 5 and 6, because it's about 5.5. Okay? And how do we find the value? Well, you know what? I just kind of made some guesses. I said, let's check 5.4. And we found out it's too little. So I said, let's check 5.5. We found out it's too big. So it's got to be somewhere in between that. But you know what? 5.5 is pretty close. Right? 5.5 is probably a little closer than 5.4. So I'll go with that. How can we approximate the side? We can guess. Right? We can guess. We know that it's between 5 and 6. So we just started guessing. And it comes out to be about 5.5. Now, how do we find the exact value? Ultimately, we want to know some number squared equals 30, and we want to know what that is. And it turns out that number is called irrational. It's going to keep going forever and ever and ever. If it doesn't come out to be a nice number, it's going to keep going forever. And so we actually square root both of these, and then that tells us that whatever number this is, that's actually equal to the square root of 30. And then we can use a calculator. And I got a little calculator here. Maybe yours doesn't quite look like mine. That's all right. So on my calculator, I have a little square root button right here. It's right above the x squared. And in order to get to that, I have to hit Shift, and now I hit that. And you can see it now, it puts a little square root there. And then I put 30. Now, maybe your calculator doesn't quite look like this. If you don't have one of these graphing calculators, and if you have a smaller calculator, there's a good chance you actually have to put 30 first and then hit the square root button. Okay? So if you just try hitting the square root button, it might just give you like 0, or it might say error. So if you don't have a graphing calculator, you're probably going to have to hit 30 first and then you hit the square root button. Okay? All right. Stop jumping around. You did it again. Wow, this just really wants me to show you something up top, I guess. Okay. This table here just shows you what I was just talking about with that little square root. So this square root means like that you want to try to break the number apart and figure out what times itself gets you 16. Because 4 times 4 equals 16, then the square root of 16 equals 4. Okay? So that's all this symbol means. It means it like figure out what number times itself gets you that. Okay? So let's look at using that square root a little bit more here. The square root of 64. It means, like, just like up before, if we had a square and I said, hey, the area is 64, how long is a side? And you would say 8. That's what this square root symbol means. It means what times itself is, in this case, over here on part B, what times itself is 100? You would say 10. What times itself is 81? 9. Okay, fractions are no different. That's just fine. Because look at this, you can think of this, there's actually a property with radicals that says I could break this up and make this the square root of 9 over the square root of 16. Right? The square root of 9/16, I can just split it up like this. If I do that, now I know the square root of 9 is 3, and I got to say the square root of 16 is 4. Now, sometimes decimals are a little bit tricky, but you could think of this as a fraction. I know you're like, fractions, why would I do fractions? Well, 25 is 1/4, and that's just square root of 1 over square root of 4. Sorry about that. There we go. So the square root of 1, of course, is 1, and the square root of 4 is 2. It gets us 1/2. Now, maybe you would rather stick with decimals, which is just fine. 0.25, what I would think of here is what times itself gets me 25. I'd say, oh, 5 does. But I know the 5 times 5 is 25. I need it to be 0.25. How about if I do this? Now I can check it. 0.5 times 0.5 gets me, let's see, that's 25. And then I would say I have 1, 2 decimals. So 1, 2. There we go. 0.25. Like I said, I actually really like fractions better, but I get it. A lot of people don't. It's okay. All right, the next one here, notice is a nice little fraction. Square root of 16 is 4. Square root of 49 is 7. And we just get 4/7 for our answer. Okay. Now, some of those other numbers that I talked about earlier are called irrational numbers. And I told you they keep going. This is a decimal the decimal representation of it never ends, it never terminates, and it doesn't repeat. There's no repeating pattern. It doesn't go like 1.2343, 2343, 2343, 2343. Okay, that's not the case. An irrational number like this, a square root, this is actually a whole different number set than those numbers that could be written as a fraction. Okay, so these are called irrationals. So it's a totally different number set. And it just means it's a decimal that will keep going, 4, 1, 4, 2, 1, 3, 5, 6, 2, 3. There is no pattern to it. There's no pattern. Okay, it's irrational. It's just going to keep going. You can do decimal approximations using a calculator. I've already shown you a calculator. Let's go ahead and we'll use that calculator to figure out which two integers radical 75 is in between, and then we're going to justify our answer to use a calculator. So radical 75, what I like to think about is I like to think about what each number squared is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just go up to there for now. And 1 squared is 1. 2 squared is 4. 3 squared is 9. 16. 25. This was part of a list that we had up there earlier. I just didn't want to scroll up to see it. 49, 64, 81, and 100. So 75 actually falls right between 64 and 81. That means it's going to be right between 8 and 9. Okay? So this is between 8 and 9. The reason that we can justify that is because we could think of it like this. Radical 75 is between 8 and 9 because if I square each of these, I end up getting 64 is less than 75 is less than 81. And that's true. 75 is between 64 and 81. Therefore, if we square root all of them, we get 8 is less than or is less than radical 75 is less than 9. Now, if you put radical 75 into your calculator, we're going to get a decimal. And this says to round to the nearest thousandth. Tenths, hundredths, thousandths. 8.6602. Okay, so 8.6002. Oh, I wrote it wrong. 6602. That's an easy fix. There we go. And now the thing is that I want this to be rounded to the nearest thousandth, so I've got to look at this one. I notice this 2 is very small. Because that's less than 5, it just gets chopped off. And so my answer to this then will be 8.660 is what this would be rounded to the nearest thousandth. Okay. Let's do these next couple. Again, round them to the nearest thousandth. So square root of 3, I'm just going to put in square root of 3. Remember, you might have to hit 3 and then square root. Just depends on your calculator. I've got 1.7320. Well, that's a no-brainer. Tenths, hundredths, thousandths. So if I look past this, I get a 0. Of course, we're going to chop that off, and I just get 1.732. Okay. Square root of 27. We'll put in square root of 27. 5.1961. And then this one right here is little. That means I'm just going to chop them all off. So 5.196. Maybe on this next one you go ahead and do it on your calculator and then see if you get the same thing I do. So pause the video here and go ahead and do this one. Make sure you get it before I do. Square root 108. There it is. 10.3923. Okay, so 10.3923. So this last number here, again, it's less than 5. That means we're just going to chop it off. It's like rounding down. And that's how we get then 10.392. Okay. Consider radical negative 49 or radical negative 25. In other words, what times itself equals negative 49? And you might first respond by saying, well, obviously it's 7 and 7 is 49, so it must mean that negative 7 and negative 7 is... Oh, wait a minute. Negative 7 times negative times a negative is a positive. So that can't be true. But a positive times a positive is a positive. So I got to think what times itself gets me a negative number. Oh man, I'm stuck. Guess we better go to the calculator and see what the calculator says. So square root negative 49. What do you think is going to happen? Is my calculator going to blow up? Is it going to say, is it just going to, no. It says no, that's non-real. Now, this is actually very specific. And I love that my calculator says it this way. Not all calculators do. Some of them say, some of them just say error. And I guess that's not wrong. The calculator's not programmed for it. And some teachers, maybe that aren't careful, will say that it's impossible. And if you have teachers that are very careful, they'll say non-real. Or they'll say, you know, it's impossible in the real number system. Or we can't do it in this class. Because we actually can do it, but it's for a more advanced class. So all we focus on at this level right now are real numbers, okay? And that's not I'm just not throwing that around. Like, that's actually a classification of numbers, and we talked about those early in the year or in a previous class, just depends. But so this is a non-real. This is what we call an imaginary or a complex number. Okay, so no, we can only take the square roots of positive numbers. Okay, so just keep that in mind as we're working. Now, Pythagorean theorem is going to be finding the side length of an unknown side of a triangle. Okay, so this is a very, very famous theorem. And why don't we'll just go ahead and save this for next time, I guess. So I'll put this up in another video. So hopefully, I should have stopped there, but this is all nice as far as square roots and radicals. That's pretty good. All right, I'll see you in a little bit.